Welcome to Milestone 7. From here things get quite interesting because we're now going to simulate protecting a nuclear power plant using the technology, and you'll get the opportunity to create a defense template which other people will begin to attack later on in the course. First, let's understand where we're at in terms of the TACE theory. There's 6 layers to the TACE theory, and we've accomplished 2 of those, the alpha and beta environments. But even at this stage, we can already protect against remote attack. We can protect against logic bombs, and that's enough for us to begin the hacking challenge. It's also got implications for cloud computing, which currently suffers from a number of issues, one of them being unable to protect the client virtual machine, and the other is, of course, information leakage, which is addressed later on in TACE. But the inability for cloud service providers to protect their virtual machines is a serious concern for people adopting clouds today. So first, let's have a look at the architecture. And you can see in this diagram here that there's 3 templates. There's the server template, which is what the OpenVPN server is executing on. Well, we're going to just ignore that, not to worry about that. That's just infrastructure. And there's on the left the attack template, and on the right the defense template. The attack template will be used by your adversary to attack your build, and what we're concerned with in this milestone is the defense template. And if we look at that defense template, we can see that it's got a core node and an access node running on it. The core node is what we want to protect, and we're going to build some software and access node that's going to just routinely call a few methods on that core node using what we've learned so far, the context reduction engine. And on the attack node, there's what we're calling the outsource node, which will be written by your adversary. In the scenario that we've described here, the outsource node is being developed by an undercover spy developer, and of course you don't know that they're working against you and that they're trying to put in a logic bomb. But the theory says that you should be safe because they're running everything through a context reduction engine, and the peer node cannot attack your node which is running on the core in the defense template. Now I'm going to talk about why this configuration is in fact secure. Well, if you look on the attack template, you can expect your adversary to install any kind of penetration tools such as Metasploit or any commercially available tools. Now these hacking tools will scan for ports that are open on the defense template and attempt to find vulnerabilities and then perform an exploit and break in. Now the reason these traditional hacking tools will be unhelpful, and this was really the topic of the 2010 study, is that there's only one available port that's open on the defense template, and that's currently set to 10,000. So there's no doorway for the hacking tools to break in. So the only way to get into the core node is through port 10,000, and of course the outsource node, which is already provided here, will make that connection. So part of the security premise is that the BI3 will already anticipate that its connection to another peer will be untrusted, and so the protocol is designed to prevent an escalation of privilege and attack from the outsourced node. So there's no risk for a connection violating the core node directly. Now, the only other avenue that we've studied for information to gain a foothold is the actual data that's travelling through that connection and the way that it's interpreted, and that's the purpose of the context reduction engine itself. And you won't be able to really find a way to overwhelm that context reduction engine because it's designed to be very narrow in this example. You'll need to study the notes on context reduction engines to understand how that works. So those are the main ways of attack. The only other alternative way in, of course, is for some code to try and attack the host, but the malicious client problem is already prevented because those classes are scanned for any library calls. So without any library calls, there's no way to actually create any change in the environment, and so the malicious client problem is not an issue there. So there's no way for you to actually attack the core node, but you can still get information in and out of the core node using that context reduction API.